Okay, so 4B.2 is going to be talking about triangle congruence and how we can prove triangles are congruent. So the first two ways that we're going to talk about are side, 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 and side, angle, side. So if we start with side, 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 this is just basically saying that if you can prove all three sides of the triangle congruent, then it's going to be congruent triangles. Okay, so in our picture here, if we can show that AB is congruent to DE and BC is congruent to EF, and then AC is congruent to DF, right, then we can say that those triangles are congruent. So then we can say that triangle ABC is congruent to triangle DEF. Just make sure that your congruency statement matches and that all the sides correspond are congruent. Okay, so then when we actually get into proofs, okay, we've done proofs before, so we have to use like theorems, definitions, postulates, that kind of thing to prove. So anytime we start a two-column proof, we want to start with your givens, and in this case we have 3. Okay, and what I like to do is mark up the triangle based on your given, so you know that PQ is congruent to ST. You also know that QR is congruent to TR, and you know that R is the midpoint of PS. Okay, so we start with all 3 of our givens. We're trying to prove these triangles congruent by saying all 3 sides are the same. Well, we have 2 out of the 3 sides. So to prove the third side congruent, well, if that's a midpoint, we can say PR is congruent to SR, because that's exactly what a midpoint is. So we would say definition of a midpoint. All right, and then once I prove all 3 sides congruent, I can say that the triangles are congruent because of side, side, side. Okay, so if we look at another one, okay, again, we always want to start with our givens, and in this case we have 2, so I know that JL is congruent to NM, and that K is the midpoint of JN and LM. Okay, well, if K is the midpoint of JN, that cuts it in half. So I can say JK is congruent to NK because the definition of a midpoint. Okay, same thing with LM. It cuts LM in half. So again, those are going to be congruent because of definition of a midpoint. Okay, once I proved all 3 of those sides congruent, we can say the triangles are congruent by side, side, side. Okay, the next one that we're going to try is side, angle, side. Okay, so you're proving 2 sides congruent, and then the included angle, that's pretty much the most important part, is that the angle is in between those 2 sides. Okay, so if I can prove that AB is congruent to DE, and I can prove that BC is congruent to EF, well, that included angle is going to be angle B and E. So I can prove angle B is congruent to angle E. Okay, so just make sure that your angle is pretty much sandwiched in between your 2 sides. Okay, so if we look at our first proof, again, we always start with our given. Go ahead and mark up your triangle as you go. So JM is congruent to LN, and then angle JMN is congruent to angle LNM. Okay, that's also given. Okay, and we've talked about this property before, but when we have MN congruent to NM, that's saying it's congruent to itself. Okay, and that's going to be our reflexive property. Okay, so even though it looks pretty obviously like, yeah, we obviously know that it's congruent to itself, we didn't mark it up on a triangle, so that's why we have to add a step, and that's why we have to say it. Okay, so then our last step is to say our triangles are congruent, and that would be by SAS, because our angle is sandwiched in between those 2 sides. Okay, so if we take a look at another one, we're going to start with our given. So AB is congruent to CB. And then BD bisects angle ABC. That's going to be that's also our given. So we do know that BD is a bisector. Okay, and it's bisecting angle ABC. So what that does is it cuts it in half so that those two halves are equal. So that's step 3. ABD is congruent to CBD. That's because it's the definition of angle bisector. Okay, and then that same property shows up again. BD is congruent to it, BD, so congruent to itself. That's going to be our reflexive property. And then we can say our triangles are congruent because of SAS. Okay, so on this next part, it's kind of going to have mixed proofs in there. So some will be side, 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 some will be side, angle, side. But we do want to start all of them the same. So obviously we're going to start with our given. So V is going to be the midpoint of two things. Okay, so WV is going to be equal to ZV, and that's going to be because definition of a midpoint. Okay, and that's also going to be the same reason for our statement number 4. Okay, and then statement 3, so WVX, so this angle right here is going to be congruent to ZVY. Okay, so anytime we're looking at angles, the best thing kind of to do is figure out what angle relationship is being shown. Okay, and that's going to be vertical angles. Okay, so then we have two sides and an angle sandwich in between, so that's going to be side, angle, side. Okay, so on number 6, again, we have two givens. Given. We know two things. I know that HI is congruent to JG. And I also know that those are going to be parallel. Okay, so if they are parallel, then we should be looking for angle relationship. So GJH is congruent to IHJ. Okay, so that angle relationship is going to be alternate interior angles. Okay, so then the next one is HJ is congruent to JH. That's saying it's congruent to itself. And that is that reflexive property. And then we can say the triangles are congruent by SAS. Okay, so then on these problems down here, we're basically deciding if we can prove them using SAS, SSS, which one we can prove them with. Okay, so if we look at our first example, okay, we have two angles and a side, or sorry, two sides and an angle. Okay, and that angle is sandwiched in between, so that is going to be SAS. And then we would write our congruency statement. So triangle T, actually let me do triangle, it really doesn't matter the order that you do it, so I'm just going to do triangle QYT is going to be congruent to CKP. So again, just making sure that your congruent sides are corresponding. Okay, the second one, all the sides are the same because of this reflexive property in the middle. All right, and we would say triangle ACD would be congruent to triangle ACB. Okay, so the other one that I do want to talk about is this one right here. Okay, and the reason why is because the angle that they give us is not the included angle. So these are going to be not congruent. All right, okay, so you guys can practice these 3 problems, and then after you do these 3 problems, these last 3 proofs, y'all are going to try to write the statements on your own and then write the reasons as your own. And then there will be a key on Canvas so you guys can check your answers.